Hey guys, we're starting our work with periodic functions. We're going to be spending some time working with this and talking about trig functions in the near future. And I just wanted to go over a few definitions that we're going to be seeing and some of the things we're going to be talking about. Alright, so first off, what is a periodic function? Well, a periodic function is a function whose graph forms a repeatable pattern. It's something that happens over and over, and if you were to graph everything out, it would continue doing this pattern in both directions indefinitely. So for instance, here is an example of a periodic function. You can see it kind of goes down and up and down and up. And one of the important things to note is it's all going, and it's got the same minimum and the same maximum all the way across. It's not getting higher and then lower. It's staying relatively the same, even though it is going up and down. This example over here is not a periodic function. This is a non-periodic function because even though you can see that there is a pattern, it is slowly going down with its waviness, and this makes it non-periodic. We've got to have it stay relatively at the same level and have what we call the same midline. All right, a couple more definitions. First off, we've got this nice little diagram up here, and this is going to help us out here. First off, the period length, and this is how long it takes for the cycle to repeat, or how long for the pattern to repeat. And this is the length of one cycle, and some of the problems we're going to be seeing, we're going to be actually either counting the length or calculating the length, depending on what we're given. But for instance, this right here, going from this point on the bottom over to here, that would be our period length. That would be the length of our cycle. And we don't necessarily have to calculate it from these points on the bottom. We can calculate it from 2 points on the top. We could calculate it from a point right here in the middle and then going over to that same point over here as it's coming back down in its cycle. The amplitude is the other thing that we're looking for, and the amplitude is half of the distance between the maximum and the minimum. So it's basically the distance from this dotted line in the center, which we call the midline. It's the distance from here to here, and we figure out where this midline is because we take the maximum minus the minimum, and then we divide by 2, or we multiply by 1/2, and that'll give us where this little dotted line is, and that'll also give us where the or what the amplitude is. So these are some of the things that we're going to be encountering over the next couple of weeks when we're looking at these problems.